Hi guys, ready for another stream, another Saturday. Okay, so we're waiting for a few more folks to join in and then we'll right off go into our session. By the way, I've changed my space and view as well, angle as well, so things should look much better now starting from the stream. Okay, so just say hi in the chat if you guys have already joined in. Okay, a few more folks have joined in. Just say hi in the chat, guys. If you are live watching this stream, let me know if anything is off, you're not able to hear me, or if my display is not good, let me know. Okay, so Manish is here. Let's wait for a few more folks. Hey, Alex is here. Thanks, Alex. Okay, give a few more minutes before we start. So we have seen people started to coming in. Guys, just say hi in the chat once you are connected, once you can see the screen and everything, so that I know everybody's here and we can start. Okay. So by the way, we have covered a lot of different topics. We started, like, this is going to be my 6th live stream. Okay, so we've covered from basics of serverless to AWS CLIs to now to deploy serverless on on-premise cloud. Then we covered what we could do with SAM. And then we went from there to understand how can we deploy different things with Lambda. What are the best practices around creating an end-to-end serverless stack? Today, however, see, whatever application that you develop, right, all those application needs a backend, needs a data repository where you can store all those information and use it for interaction on the front end side, right? So that's where I was searching for a right person, who could represent this topic, and there I don't think that there could be anybody else representing this much better than what Alex could do. To give you guys a background on what like who Alex is. So if you're talking about DynamoDB, Alex has written books on DynamoDB. He's been very vocal about things related to how should you organize your data structures, how should you implement you know serverless database in your serverless stack, right? And other than that, he is basically like he's an ex serverless Inc. guy. So from there, he's been working on his own independently, and that's where I've come across him. I was reading a lot of stuff on DynamoDB when I wanted to implement that in one of the products that we were building, and that's how I've come across a lot of blogs that he has written, a lot of good posts he has written to kind of guide you on what's the best way of implementing DynamoDB for your serverless stack. And other than that, he is AWS data hero. So yeah, he's been recognized for his efforts on uh, database and all those aspects as well. Okay, so before we take much time, I wanted to start the session, but guys, I just have 2 comments in the chat. So rest of you guys, if you can see, if you can hear, just say hi in the chat so that we can start the session. By the way, Alex, because of the time difference, a lot of folks, I cannot ask them to be with us for the full 1.5 hour. Okay, so what I've like all this time difference and everything, they have recorded, a session for us, and that's what we are going to go through together during this live session. And then he is available for us to answer any question. He's going to join us live. Okay, Kush is saying hi. Wow, only 7 watching today. What happened to the counts? I hope there is no glitch on the YouTube side. Anyways, so let me start the session. Let's not wait for more people to join in. Okay. Uh, just hold on a minute. I'm gonna go off and the video would start soon. Just a second.
All right, hey folks, I want to talk to you about serverless architectures. And if you're doing serverless, serverless isn't just about fast, but it often starts with fast functions as a service. So AWS Lambda is often the core of your serverless architecture. But Lambda by itself isn't particularly useful, right? You need to hook it up to some event source to actually trigger this Lambda function. So maybe you add in API gateway, right? So you can handle HTTP requests. Someone makes a web request to your backend application. That triggers a Lambda function and you do something with it. But then even then in your Lambda function, you can't just do anything with it directly in that Lambda function. Usually you're interacting with other services in the backend. And that might be something like Amazon S3. Maybe you need to save a file or retrieve a file and return that to the client. It might be something like SQS to enqueue a message into a queue that you can then process later. And in reality, you're probably using a lot of different services in your application architecture. Things like EventBridge, Kinesis, SNS, lots of different Amazon services that you can use. But really one of the more important decisions you're going to make is around your database, right? You need some sort of persistent data storage you can access quickly and flexibly, and you need to make a choice. And you have a lot of different options within the AWS ecosystem. You can use something like Amazon RDS if you want to use a relational database like MySQL or Postgres or something like that. You can use DocumentDB if you're familiar with MongoDB and want a more document data structure. You can use DocumentDB for a managed experience there. But really one of the more popular ones is in the middle there, Amazon DynamoDB, and that's what I'm going to talk to you about today. Right? Amazon DynamoDB is this NoSQL database that works really well in serverless applications, and we're going to discuss why it works so well in serverless applications and why it's become the database of choice for a lot of people that are doing serverless applications. So this talk is about implementing DynamoDB in serverless applications. I want to talk about 3 things in this talk today. First of all, we're going to talk about why DynamoDB in serverless. Why are so many people choosing DynamoDB in their serverless application? Why does it fit really well there? Once we've done that, then we're going to talk about the basics of DynamoDB data modeling, because data modeling in DynamoDB using DynamoDB, a relational database that you might be used to. So I want to talk about some basics there and get you some understanding of what that data modeling looks like. And then finally, I'm going to leave you with some tips for successful DynamoDB implementations. This isn't going to be a huge deep dive into DynamoDB data modeling because that's a pretty broad topic, but this will at least get you started with some tips there. So who am I? I'm Alex Debris. I wrote the DynamoDB book recently, so I've done a little work in this area. A couple of years ago, I created DynamoDBguide.com, which is it's a free resource out there to learn about DynamoDB, so go check that one out. I'm an AWS data hero due to my work with DynamoDB and been honored to do that and talk at reInvent in AWS summits, things like that. And I'm just a general AWS and serverless fan. I used to work for Serverless Inc. for a long time, so we created the Serverless framework, which is a really great way to deploy your serverless applications. I work there, been involved with the community, really like the serverless community. I mentioned the DynamoDB book earlier. I released that a couple months ago, and I think it's the most comprehensive guide to data modeling with DynamoDB that's out there. Because again, like I was saying earlier, data modeling with DynamoDB is pretty different than with a relational database. So pretty in-depth book. It's 450 pages, and it's got a bunch of extras and additions if you want to buy that sort of thing. It talks about how to handle relationships. It talks about how to do sorting, filtering, handle uniqueness, all sorts of stuff. So, really core things to your applications. It's going to walk you through all that. And then really just to get to the meat of it, it has some walkthrough examples, some really in-depth examples, including replicating the whole GitHub backend. So if you want to talk about users and organizations and repos and issues and stars and pull requests and forks and everything like that, we'll show you how to do that in DynamoDB. And you can do more than just key value storage, which is what some people think DynamoDB is used for. So go check that out. You can find that out at dynamodbbook.com. So let's get started by talking about why DynamoDB and serverless. Why are so many people choosing DynamoDB to use in their serverless applications? And I think there are 5 big reasons. So the first one I want to talk about is just the interaction mechanics and what it feels like to use DynamoDB and how similar it is to using other AWS services. So if you've used some AWS services, you might have something like this. This is working with SQS, which is a queue service from Amazon, and basically it's a 3-step process whenever you're interacting with an AWS service. First you're going to import the library. So this is in Python. I'm importing Boto 3, which is the AWS SDK for Python. Then I'm going to create an instance of my client. This client is using SQS as noted there. And then once I've done that, then I'm going to call a method on that client. So I'm going to call send message here, which is going to send a message to that queue and queue that message to use it. If I'm using Amazon S3, right, which is a blob storage service from AWS, very, very widely used and well-loved service. Again, the mechanics are the exact same. You're going to import the library, you're going to create the client, and then you're going to call the method on that client. Now, if you're using DynamoDB, those interaction mechanics are the exact same as they are for SQS, for S3, for any other AWS service. You're going to import the library, you're going to create the client, and you're going to call the method on that client. And this is great, a very consistent usage pattern there across, and just feels like using any other service. You can contrast that with other database options, which might have a more persistent connection. You need to sort of set this up in a different way and maybe handle connection pooling, whereas with AWS DynamoDB, you're calling methods on this client, interacting with just HTTP calls. So that's the first reason why people are loving DynamoDB and serverless, right? The interaction mechanics are really pretty similar to other AWS services. The second reason a lot of people love DynamoDB and serverless is around the permissions model and how well that integrates. So this is a little blurb that I have from my serverless YAML file. This is if you're using the serverless framework, but it's going to be similar if you're using something like SAM or other serverless tools. But basically, you're going to use AWS IAM to give permissions to your Lambda function about what it can and can't do. And if you look here, at the very top, I'm giving some SQS permissions here. So that first example I showed where it was in queuing a message into my SQS queue, this is how you would allow that function to do that. You're going to give it the particular action, SQS send message, and on a particular resource, give it that queue ARN. Now, working with DynamoDB is the exact same method. It has the same mechanics here. You're going to list out the different methods it can use. It can do get item, it can do put item, it can do query on this particular table. It feels very similar permissions-wise as using any other AWS service, which is a nice fit within that Lambda ecosystem. Again, if you're using something like a relational database, now you'd have to have sort of this different provision model that's in the relational database itself. You have to create your users and groups and roles and all that thing, and which tables they can and can't access and in which ways. And it's just a different model than the AWS IAM. So it's nice to say in one sort of consistent ecosystem there. Another thing that's great about the permissions model is those permissions are handled for you. So when you have your Lambda function, you have an instance, it's going to get temporary credentials that are injected into that Lambda function. So it's going to have your AWS access key and a secret access key just injected into there for you. Those are going to get rotated automatically for you. And then those credentials are automatically discovered by the AWS SDK. So when you're importing your library, creating that client, it's going to be able to pick up those credentials from your environment. You don't have to worry about it. You don't have to worry about credential rotation, keeping those secrets safe, injecting them into your application like you would with a relational database connection string or something like that. So that's really great. It fits well with the Lambda model there. So that's the second reason. Permissions model works really well with DynamoDB and serverless. The next one, and sort of on the same tack here, is the provisioning model works really well with DynamoDB and serverless, and it feels the same to provision a DynamoDB table as it does to provision any other resources. So again, I got a little example, CloudFormation here. This could be in your serverless YAML if you're using the serverless framework, or again, it's SAM if you're using that. But basically, you can use CloudFormation to provision resources using an infrastructure as code model. And again, it feels very similar to use DynamoDB as it does for other AWS services. So at the top here I'm provisioning in SQSQ. Again, using that SQSQ as an example because it's very similar to use a queue and use that DynamoDB table. So at the top there, I'm provisioning that SQSQ in CloudFormation. And then at the bottom there, I'm provisioning that DynamoDB table. And the syntax, the mechanics are very familiar between these two. And it's nice because then you only need to learn one system. You don't have to learn multiple systems. Again, if I want to contrast that with a relational database, maybe you can provision the relational database itself using CloudFormation, but then you need to handle these other things sort of out of band of CloudFormation, including creating those users and groups and roles that we were talking about earlier around permissions, but also creating your tables, adding your indexes, adding different things like that. So it's a little more difficult to handle that in an infrastructure as code way with a relational database. That's the third reason people love DynamoDB and serverless. The fourth reason is the billing model, and the billing model with DynamoDB fits well into that serverless world. So basically, you have two options of billing modes you can use. You can use provision capacity, or you can use pay per use. So let's walk through those two modes. Provision capacity, this is the one that's been around for a while, but you can think about it similar to EC2 or any other database where you're sort of choosing some capacity in advance and you're paying for that whether you use it or not. And with DynamoDB, you're paying for your reads and writes, but you can choose to have that capacity provisioned in advance, and if you exceed it, you're going to get throttled. They also have a newer billing mode that's just a couple of years old. It's an on-demand or a pay-per-use mode where you just pay for every read and write request that comes in. You don't need to provision that up front. You don't need to do capacity planning, think how that translates to queries, anything like that. It just, you pay as you go, which is really nice. Again, it fits into that serverless world where you're paying per use for your Lambda function or for API gateway or for SQS or S3 or anything like that. The other thing that's really nice that I touched on a little bit, but you're paying for reads and writes directly rather than paying for resources. And this is pretty interesting because usually when you're doing capacity planning, you're saying, okay, I'm expecting to have this many users come in, which means this many requests per second, which means this many hits on my database. And then you have to guess, okay, what does that mean? How do I translate that to CPU and RAM, right? Because you don't really know how it's going to work. And there's a little bit of a black box there of how that translation works and can be tricky. With DynamoDB, it's a lot simpler. You're not paying for CPU and RAM. You're paying for the amount of read and write units you use. So a read unit allows you to read 4 kilobytes of data. A write unit allows you to write 1 kilobyte of data. Those are both on a per second basis. So you can just think about if I'm doing 1,000 queries a second, and each one of them are this many kilobytes. Like this is how many read and write units I need. And it's very easy to make that calculation rather than guessing and grasping at how much CPU and RAM you need. So I think that's a huge benefit of the billing model of DynamoDB as well. That's the fourth reason that people love DynamoDB and serverless. The last reason people love it is just the scaling characteristics of DynamoDB, right? And when you have AWS Lambda, which can, you have your compute environment, that one of the great benefits of it is you don't have to sort of pre-provision all this capacity. You can just sort of scale up as you want, which means you can go from 0 requests to 1,000 requests immediately. But DynamoDB can handle that as well. And one thing that's great about DynamoDB is it's built to handle really huge scale increases. It was built for the scale of services that were outscaling the relational databases. So you look at things like Amazon.com retail, the shopping cart there, right? They couldn't handle the amount of scale they had on Prime Day or Cyber Monday with their traditional relational databases. So they built the underlying technology of Dynamo to handle this. So they can really handle huge scale applications, and you see companies like Lyft and Uber and Airbnb using this for the really high scale applications. And the great thing about DynamoDB is you're going to get the same performance at 1 gigabyte as you're going to get at 10 gigabytes or 100 gigabytes or terabytes and terabytes of data. So it's really just amazing, consistent performance. The other great thing here is that it really scales in the amount of connections you can have. So when you have a relational database, often you're going to have a limit on the number of active persistent connections to it. Usually 200, maybe 300 active connections there, which can be a problem if you have all these little Lambda functions spinning up everywhere and setting up these connections and reusing these connections. You can hit connection limits, which can be a problem. DynamoDB, you don't have that problem. It's going to connect over HTTP, very friendly that way. And not going to run into connection limits. So you don't have to worry about managing that in your Lambda function. So now that we know why you might want to use DynamoDB in your serverless application, let's talk about some basics of data modeling with DynamoDB. Because again, like I was saying, it's very different than working with a relational data model that you might be used to. You really need to do some different things. So let's get us all on the same page there. First thing I want to talk about is just some vocabulary, some terminology to get us all on the same page. And there are 4 terms I want to talk about first. Those 4 terms are table, item, primary key, and attributes. Now, as I work through these 4 terms, I'm going to use an example just to illustrate what this looks like. So imagine you have an application that has some authentication, some sign-in component. And as part of that, when someone signs in, you'll create them a session token, store that in a database, and give that session token back to them. And then they'll include that on subsequent requests that you'll use to authenticate them. So you're creating a session store here. And here's an example of our session store. We've got 4 records in there, different Marvel characters. If you look at all those records together, those are going to be contained in what's called a table. So a table is all of your data together, and it's going to be similar to a table in a relational database, different in some ways as well. Or if you're coming from MongoDB, this would be similar to a collection in MongoDB. Now, if you look at an individual record, like this one for Black Widow, that's going to be called an item. So one record is called an item. That's going to be all the data attributes that are contained on an individual record all together as an item. Now, when you create your table in DynamoDB, you need to specify what's called a primary key on your table, and every item that goes into your table must include that primary key. So the primary key is going to be very important for data modeling. Every item needs to have it, and each item in your table needs to be uniquely identified by that primary key. So you can't have 2 items with the same primary key. They would just overwrite each other in that case. So in this case, we're using session ID as that primary key, that identifier for that item. In addition to your primary key, you can have additional attributes on your table. So here we have username, created at, expired at, things like that. You don't need to specify these when you create your table. So DynamoDB is called schemaless in that way, where you don't need to define your schema in advance like you would in a relational database. It also means DynamoDB is not going to validate your schema outside of that primary key. So you need to make sure you do that validation in your application. So it's not that you shouldn't have a schema anywhere. It's just it's schemaless in terms of the database itself. That's not going to validate it, but your application should do that validation for you. Now, we talked a little bit about primary key, and I want to dive deeper into that because it's very important. So there are 2 types of primary key in DynamoDB. One is called a simple primary key, which is just composed of just a partition key. And then there's also the composite primary key, which is made up of 2 parts, a partition key and a sort key. So let's take a look. That example we've already looked at, that's a simple primary key, right? It just had one element, that session ID, which is the partition key in this case, that uniquely identifies each item. Let's look at an example of a composite primary key. So in this example, we're going to use actors and movies that they've played roles in. So this is like an actors and movies table, storing all the different roles for these actors. And you can see we have a composite primary key that's made up of 2 different elements. The first part, the partition key, is made up of the actor name. So you can see we have Tom Hanks, Tim Allen, Natalie Portman, and then the sort key is movie title. So that's the movie that they've played a role in. So we have Castaway, we have Toy Story, we have Black Swan. Now, when you're using a composite primary key, it's the combination of those 2 elements that identifies whether that primary key is unique. So in this case, it's okay that we have 2 items with Tom Hanks as the partition key. That's okay because they have different sort keys, different movie titles that allow them to be unique as a combination. Likewise, we have 2 items that have Toy Story as the sort key, but because they're different actors, different partition keys, that's okay. So those are the two primary keys. Primary keys are going to be very important for your data modeling, and we're going to see a little bit more about that. So, but one thing I want to talk about before we talk more about data modeling and some unique parts about DynamoDB's data modeling, this is what I call is DynamoDB's guiding principle, and the principle is do not allow operations that won't scale. I mentioned earlier on how DynamoDB and the guts of it were really designed for enormous scale applications like Amazon.com retail. And as they were designing this database, they don't want to have operations that work at 1 gig or 10 gig or in your test environment that aren't going to work in production or aren't going to work when you scale up. So what they've done is they've sort of taken off features of relational database that won't scale up and make you be more intentional about your design up front. So I think it's useful to understand that underlying context, to understand, DynamoDB might feel hard and might feel different. And the big reason is because of this. They don't want you to get into a place where something that worked at small scale no longer works at large scale, and now you have to refactor your entire application. So let's see a little bit about the basics of data modeling with DynamoDB. Number one is going to be the importance of the primary key. So if we go back to that example we had before with the movies and actors and the roles they've played, we've had that primary key of actor and movie, the actor's name, the movie name. We also have those other attributes on there, the role that they played in the movie, the year that the movie was released, the genre of the movie, is it drama, is it children's, different things like that. Now, when you're working with DynamoDB, all your query patterns happen on that primary key. So, you can query by Tom Hanks and say, give me all of Tom Hanks's movies. Or you can say, give me all of Tom Hanks's movies whose movie title is between this and that. You can use those attributes to query, but you can't query on those attributes. You can't query this table on that role directly. So you couldn't go and say, hey, who played Buzz Lightyear? You wouldn't be able to query that. You'd have to scan the entire table for that to happen, since it's not in your primary key, which isn't going to be efficient. So primary key is very important. This is different than a relational database where you can really query on any attribute, and you add different indexes, things like that to make it faster, but very flexible patterns. So this is going to be different for you there, and we'll talk about other strategies for that. So that's one of the big important things about DynamoDB data modeling. Another important thing to know is that there's no join operation in DynamoDB. So, when you're using a relational database, you have two different tables. You have this normalized data. Maybe you have customers over here. Maybe you have orders over here, and you join them together to find, information about the customer when you're grabbing a particular order to have that work. In DynamoDB, there are no join operations because joins don't scale well. They make it hard to horizontally scale your data. They also, if they get really big, they don't work as well either. So let's talk a little bit about that, because some people are like, why can't I do joins in DynamoDB? And I want to show a little bit around how DynamoDB can handle your data because it doesn't allow joins. So let's start off here. And when you think of DynamoDB, you're thinking of this giant database table, and you think of all your data stored together. And that's actually a facade, right? All your data isn't going to be stored together. Let's talk about what's happening when you make a request to DynamoDB. So your DynamoDB table is actually composed of different partitions in the background, and you don't need to know about that or to think about this in your application that much, but I think having this mental model helps you understand how DynamoDB works. So, behind the scenes, even though your DynamoDB table looks like one giant database, it's actually split up into these different partitions that are going to hold maybe 10 gigabytes of data on, and they're going to be on different machines spread out all over the place. Now, when a request comes in, let's say that put item request comes in, you want to insert a new record into your table. Maybe this is our movies and roles table. We want to put Tom Hanks in the movie Big into our table. What's actually going to happen there is on that facade, which is actually called a request router, the first thing it's going to do is it's going to run a hash function on your partition key, which in this case is that actor field. So it's going to hash that Tom Hanks value, and then it's going to find out to which partition that item belongs. And it's going to be able to say, okay, when I hash that, look, all all the Tom Hanks data is stored on partition 1 and be able to find that. And the great thing about this is you can easily add more partitions. Now I've added a third partition here, and it scales up really well because that request router is narrowing down your data. So if you have a terabyte of data, it's going to be split into these little 10 gigabyte partitions all over the place. But this first operation of hashing it and then looking up to which partition it belongs, that's just going to be a lookup in a hash map, which is going to be an O1 operation, you know, if you're into big O notation. So that's a constant time lookup to move you from a 10 terabyte table to a 10 gigabyte partition and make that operation really quick. So by not having joins, they don't have to worry about sort of spreading the data correctly across the right partitions. It makes it a lot easier to do this partitioning strategy. So those, I think, two things are really important to understand, you know, how important primary keys are in terms of data access, and that there's no join operation. Because of those two things, I think there are three implications that you need to know about this and how DynamoDB works. The first one is that you need to know your access patterns in advance, right? So if you can only access via your primary keys, you need to know how to set up your primary keys to handle your access patterns. So if we think about that movie and actors table, you know, I want to get movies by a particular actor, but I don't want to get a role by the role's name, or I don't want to get a role by genre, or different things like that. So you need to list out your access patterns, and I recommend actually listing out, writing down those access patterns, and then as you're designing your table, you're going to satisfy those access patterns. You're going to design your table to make those access patterns work. So make sure you know those in advance. And again, this contrasts with a relational database where you're going to normalize your data first, and then write the queries and maybe add some indexes to make that work. The second implication of this data modeling is you're going to put all items into a single table. This is called single table design. This is very weird. It's weird if you're kind of new to DynamoDB. You're like, wait, why am I doing this? But you know, instead of having two different tables that you join together, you know, customers over here, orders over here, you combine them together into a single table and make that happen. This feels weird, but this is a big implication of that join operation. We're going to show how that works in just a second. And then a further implication of that is you're going to have very generic attributes for your primary key. So the examples I've shown so far, you know, they've used things like session ID or actor name, movie name for that primary key. But if you have different types of items, different types of entities, you have customers and orders in the same table, you're not going to be able to do things like customer ID or order ID for your partition key and your sort key, because some of those items won't have those attributes and it won't really make sense. You'll use these very generic attributes to handle that. So we'll take a look at what that looks like. I want to show an example here, especially to show those last 2 points, because those are pretty counterintuitive. So let's imagine we're making a SaaS application and we have two entities that we want to have in our database. We're going to have organizations. Organizations are the people that come up and sign up for our SaaS application to use it. That's who we bill. But then within an organization, you have users, because multiple people might sign in under a particular organization for this SaaS application. So if we start off, let's put two organization items into our DynamoDB table, and I've done that here. I've got an organization called Berkshire Hathaway, which is a big company in my hometown of Omaha, and then there's also Facebook I have in there. So I have two different organizations in here. I want to make 2 points about this before we put users in. So first of all, let's look at that primary key structure. And again, I mentioned that you're going to use very generic names for these attributes. So in this case, rather than saying something like organization name for that primary key, I've named a generic attributes like PK, which stands for partition key, and SK, which stands for sort key. So very generic attributes there to handle that rather than something specific to the item itself. Another thing I want to note here is if you look at the actual values for the primary key elements, you notice some weird things. You know, each element has this prefix of org for organization, org, hash, and then it has the organization name in there. Same thing with the sort key. So if you look at Berkshire and Facebook, they both have that pattern where you put the organization name in there with that prefix of org on it, and that helps you to identify the type of item that you want, that you're working with there. Since you're going to have different types of items, it also helps with sort of grouping in different things that you're going to need in your table. So we've got our two organization items in here. Now let's add in a few user items. So we've done that here. I've outlined the user items in red. Again, notice that they're using that same PK and SK generic primary key names there. You can also see some interesting stuff, like they have the same value for partition key as their parent organization. So you see users are in the same or have the same partition key as their parent organization, so they're sort of grouped together. And then the sort key value is going to be a little bit different pattern. Rather than org hash in the organization name, they're going to have user hash and the username. Now, we don't have time to get into the deep details of why you're doing this sort of organization here, but one thing this does allow you to do is sort of pre-join your data, because you can very efficiently get all the items with the same partition key. So what you could do here is if I wanted to get an organization and all the users in that organization and basically emulate a join like I would do in my relational database, I can do that here. I can say, hey, give me all the items with org hash Berkshire or org hash Facebook as the partition key, and it would give me both that organization item and those user items quickly, and I could give you a nice enriched view of that data. All right, so now that we know the basics about the terminology and some data modeling concepts with DynamoDB, I want to give you a few tips for successful implementations in DynamoDB. This isn't going to get you all the way there. There's a lot of nuance to it, and you really got to read up on it, but these are just a few tips to help you down the road a little bit. So the first tip I want to talk to you about, I think when you're working with your items, you should split that item into what I call indexing attributes versus application attributes, and those are very different, and I think you should keep them separate. So if we go back and look at our table that we had, our SaaS application with the organization, with the users, the indexing attributes, that's what I refer to, things like the primary key, where the only reason those attributes exist is for DynamoDB to help index and arrange your data in the right order to handle your access patterns. On the other hand, the application attributes, those are the ones that you're actually using in your application. So in this case, it's going to be things like organization name, the subscription level for the organization, or for a user, it's going to have the username, the role, maybe a birthday, different things like that, email address, right? Those are things that are actually meaningful to your application, but I would split those apart and think of them totally separately, even though there'll be some overlap between those. So, if you look at the indexing attributes, it's going to be made up of the organization name and the username of those particular items, but still keep those actual attributes separate and don't sort of cross them. As one thing you might be using with your table is a thing called secondary indexes, which we didn't cover, but it's a way for you to sort of reshape and reorganize your data to allow additional access patterns. And you're going to be using some of the same strategies from your primary key in that secondary indexing pattern. Make sure, again, just keep those attributes completely separate from your application attributes. Indexing attributes are different than your application attributes. So that's the first tip I have for you. The second one I have for you is keep the data model at the boundary of your application, right? Because if you look at these items, and especially when you start adding in those indexing attributes, those are really weird things to put in there, and you don't want to sort of mix that in with your business logic in your application. So implement your data access at the boundary of your application. You can add or query by those indexing attributes just in the very boundary, but then in the actual business logic, that's when you're working on the application attributes there. So this is an example of sort of how I implement the thing. I'll make a class for each sort of entity type that I have. So here I have a customer class, right? And it's going to have the application attributes that I'm passing into that constructor, things like the username, the email address, the name, the mailing addresses as well. Then within that, I have a pattern to build that primary key using that PK and SK pattern. So that's all encoded in this customer object that I have. And then I have a to-item method to help serialize that to a DynamoDB item. I'll also have a method somewhere to deserialize it from a DynamoDB item back into that customer object. So, just having those helper functions and making sure that data model is implemented at the boundary keeps it out of your business logic to where you don't have to worry about these weird indexing attributes. So that's the second tip I have for you. The third tip I have for you is don't reuse indexing attributes. So I was talking about, secondary indexes, how you might have these secondary indexes to allow additional access patterns, and you might find like maybe you're designing it out and the PK from your primary key and the PK from your secondary index, maybe they're the same, and you think, oh, I'll just reuse that attribute. I would not recommend doing that, and part of the reason is you're going to overload those secondary indexes. So, different entity types are going to have different access patterns on that, and whatever you use for the PK or the SK for the secondary index might not work for one item as compared to another item. So I would just separate that. You're going to duplicate some data. You're going to pay a little higher storage cost, but I think it helps your sanity there to not reuse those indexing attributes. The fourth one The fourth tip I have for you is on every single item, add a type attribute that indicates the type of item that it has. So if you look at this here, I've got the organizations and the users there, and on every single one, I'm adding this type attribute. You can see some are of type organization, some are of type user. This is going to help you for a few different reasons. Number one, if you're doing any work in the console to sort of debug your application, it can be a little easier to figure out what's going on here rather than trying to decode the primary key pattern there. Another thing is you might need to do some migrations where maybe you need to add some attributes to a particular type of item to enable new access patterns. So maybe on every user, you need to add new indexing attributes that are going to be used in a secondary index. It's going to be a lot easier when you do that scan if you can quickly find just the user items so that you can manipulate those without getting the organization items or other items in your table as well. So I think that's going to help a lot for you if you have that type attribute on there. The next tip I have for you is write scripts to help debug access patterns. So, I'm talking about, these items are going to be arranged in particular ways to help handle your access patterns, and it's going to be kind of funky. It's a little harder to just browse than it is like in a relational database where it looks like tables and like a Excel spreadsheet or something like that. It's going to be a little harder to just sort of browse through that with DynamoDB. So what I do is, if I have an access pattern, I have some scripts in my application repo where if I need to debug and get a particular access pattern, I can handle that. So, for example, let's go back to that SaaS application where I have the organization item and the user items in the same item collection using the same partition key. And maybe I have an access pattern that says, hey, give me the organization and the users for that. So this is what that looks like here. I've got those all together, and maybe that's my access pattern. It's tough to go to the DynamoDB console and sort of find the right thing and parse what's going on there. But if you maybe had an access pattern that was, get org and users, a little script that you could run, you could pass in an organization ID and it would just print that out for you in your console. I think that can make it a lot easier to work with that. So I recommend, writing scripts as you're implementing these access patterns to make it easier to find those. Those are the big ones. The last thing I can say is just you need to learn the strategies of modeling with DynamoDB. And strategies are one thing I talk about where, there's no sort of one way to do things in DynamoDB. It really depends on the needs of your particular use case and what your data looks like, how it's going to change, and how to handle that stuff. So I walk through a lot of different strategies in the book. But for example, there are 5 different strategies for one-to-many relationships. And that's going to be different from a relational database where there's basically one way you handle one-to-many relationships. You have your 2 different tables, you link them together with a foreign key, and then you handle that with a join when you do it. But with DynamoDB, there's 5 different strategies, depending on, do I want to do denormalization? Do I want to do some other types of pre-joined data? You really need to think about your access pattern. So know those strategies. Likewise, there's going to be 4 strategies for many-to-many relationships. So a lot of different things to handle there. And then also just lots of different strategies and things to know about filtering, sorting, migrations, and more. So all of this is covered in the book. I'm not here just to pump the book, but I really think you do need to learn this stuff if you want to be effective at DynamoDB. So just a quick summary of what we covered here today. I do think that DynamoDB is the best choice of database for serverless applications just because of how well it works in serverless applications. That's something we covered. So the first thing, why DynamoDB in serverless? Why is it such a great fit? And that's things like the permissions model, the provisioning model, the billing model, how well it scales, how you interact with it, just like any other AWS service. I think fits really well. Then, once we have an idea of why we want to use DynamoDB, then we went into some basics of DynamoDB data modeling. We learned the terminology, some of the concepts, as well as some of those underlying principles and how that changes data modeling with DynamoDB. Finally, the last thing we talked about was just some tips for successful implementation. So as you're working through that stuff, what are some things that can help you implement DynamoDB well in your application? I'm available for questions if you want. Again, you can find me on Twitter at AlexBDebris if you want. If you want the DynamoDB book, it has a ton of this information and more. So that's DynamoDBBook.com. I also blog. So yeah, I'm around and available, but also here to answer questions. Thank you.
That was a really insightful session, Alex.
Thanks, Ankit. Yeah, hope I didn't speak too fast there. Hope it was useful for you people, but thank you.
Yep, it does. Unluckily, I don't see the usual traffic today, but yeah, I've seen that after the session, people does go back and look at our session. So We've got good amount of views afterwards, when we do the live sessions. By the way, I don't see any questions coming in from the folks here, but I do have few questions in mind. Before we have few minutes before we wrap up the session.
Sure.
So, see, you were talking about a way, like, see, I've been meaning to use DynamoDB in applications that I build. Okay, unluckily I haven't taken that plunge yet. Okay, I've been using RDS for my whole backend, front end, everything is serverless. But when it comes to DynamoDB, or when it comes to using NoSQL databases, I'm yet to take that plunge. Okay, but my aspects are more on the operational side of it rather than the implementation side of it, right? So I want to understand that see, one thing that you outlined in your session is about how to search and do operational stuff with the DynamoDB once it goes live, right? You need to know which, like, you maybe needed to create scripts before you put that up in a production database. So you've been implementing this in a lot of different applications, right? What's your outlook on operational challenges? What are the things that we as a product company should take care when we start to implement something with DynamoDB?
Yeah, great question. So I think actually the operational aspects are very easy with DynamoDB, just because almost all that is taken care of for you from AWS. So the one thing I would say is, like, adjacent to operations, like you're saying, if you want to do analytics or debugging on your table, that can be a little bit tricky, and you need to figure out a little bit on how to do that. And I've got some stuff in the book on how to do that. But so I think that's the hardest part. But if you're talking about like what you consider traditional operations of server management or capacity planning or backups, recovery, failover, all that stuff, like most of that is taken care of for you, right? You don't have to think about servers at all, because all you're doing is choosing how much read capacity or how much write capacity I want to provision, and you can scale that up and down as you need to, or you can choose to opt out of that and just say do the pay-per-use billing model, and I don't have to do any capacity planning, which is really nice. In terms of backups and recovery, that's very simple. You can automate backups as you want to do like a snapshot backup, or you can also turn on what's called point-in-time recovery, where it's always just doing an incremental backup all the time and sort of shuttling that off to S3. And then you can say at any time in the last 30 days, if you want to, you can make you can recover from that point in time, any second in the last 30 days, which is pretty crazy. That happens just out of the box for you. Instance failover, that's totally handled by AWS. There are very few knobs you need to think about with DynamoDB, so it's pretty easy and straightforward operationally. Hold on, my kid's trying to come in.
No problem.
Okay, there we go.
Okay, so when it comes to operational stuff, what are the different parameters that you recommend to monitor? For example, when we used to work with RDS, right? How many connections which are coming in from Lambda functions, right? That's something that I keep on monitoring. CPU usage, IOs, and all those stuff that we do. But when we move to DynamoDB, I think read and write capacity is the only parameter that we need to look up to, or anything else that you usually recommend to monitor?
Yep, those are the big things I look at. So then I look at, there's basically a throttle rate where if, you provision read and write capacity units, if you do exceed that, they'll let you exceed it for a short time with some burst capacity. But if you exceed it for a long time, or if you really blow past it, then they'll start throttling you, where your read or write will be rejected because you just haven't provisioned enough. So, I set alarms on those throttle rates to make sure I'm not getting errors there. Maybe also set alarms just based on percentage of, consumed capacity. And if you do start exceeding 80%, 90%, whatever of your consumed capacity, just get a heads up so you can scale up that table as you need to. But really, those are the big things you need to look at there. The only other real concern you need to think about is, I talked about partition keys a little bit in the talk, and items are going to be split onto different partitions according to that partition key. And there are hard limits of how many requests you can do per second on a particular partition key. So this is very high numbers. This is 3,000 reads per second or 1,000 writes per second on a particular partition key. So that's not your whole table. That's just a partition key. So like one user or something like that, one organization. If you do exceed that, then you will get throttled, even if you have enough capacity provision to you just can't exceed that. So you can watch out for, am I getting throttled because of those limits or anything like that. You can also do some instrumentation in your application to check some of that stuff out. But generally, I think the throttling is the big metric that I watch for there.
Understood. So see, that basically brings me to next question. So see, if I'm a DBA, right, I used to do a lot of work with Oracle and MySQL and Postgres earlier. So we used to have this sessions, setting up with all the DBAs, setting up entity diagrams and ER diagrams and whatnot, right? And that's the process that I've been grew into that. Whenever we are setting up for a new product, we sit together and chat out. There are tools available online which helps you to plan different tables and relations and foreign keys and whatnot, right? Is there any tool which we could use to create a sort of layout for our database when it comes to DynamoDB?
Yeah, that's a good question. I use sort of a grab bag of tools depending on what I'm working on. So I would say I still make, an ERD diagram or entity relationship diagram at some point. And for that, I'm probably using some sort of ERD specific tool. I found a few on the web that I just use for that and put those together. Then as I'm sort of modeling some of that example data and building my single table to handle my access patterns, I'm usually using NoSQL Workbench, which is from Amazon directly. They have this tool that you can use to sort of create some tables, insert some data, and see how it looks in there to make sure it's working, make sure your secondary indexes are correct. So I use that. I also use, just Google Sheets usually to sort of make my entity. I call them an entity chart, which says, here are my different entities, and here's sort of the pattern for the primary key or partition key and sort key, and maybe any indexes as well. I also usually have a chart that says, here are my access patterns and here's how I'm going to handle them. It's going to use this index or this table and these conditions, all that stuff. So those are in Google Sheets. Then down the line, once I'm live in production using my table, then I'm probably using something like Dynabase, which is from a great developer named Rafał Wilinski. He's in Poland. He's made this tool that makes it easy to sort of inspect your tables, run some queries on them, and help debug there. So that can be a better tool. I was mentioning writing scripts to handle this, but Dynabase is a really great tool for handling that as well. So for me, I'm sort of cobbling together a few different things, but there are some options out there.
So, how do you decide in terms of primary keys and short keys? So do you sit with the front-end guys and back-end people who's going to design the whole system? And see, ideally what happens is in a normal product lifecycle, you design the database and the overall stuff first, right? Based on the flows that are needed, and then you go out about building the front-end and the back-end functions and everything, right?
Mm-hmm.
Is the same process be followed in designing stuff with DynamoDB as well? Or you get the overall stuff, like what are the fields, what are the searches criteria? Because one thing that I've understood with DynamoDB is I'll have to be very cautious about which fields I'm picking up to be keys, because that's where I'll be able to search. And if that is not right, I'll basically be scanning the whole table, and which is going to cost us a very huge when it comes to scanning, right?
Yeah, exactly. I would say the process is different in modeling in DynamoDB than with a relational database. So usually with a relational database, or I'd say both processes, you start with an ERD, right? And you map out your entities and your relationships. And with a relational database, you often take that ERD and ship that to the database, and every box becomes a table, and every line becomes a foreign key relationship or anything like that. And then once you've sort of modeled your data in the database, that's when you write your queries, maybe add some indexes to speed up those queries and handle that. With Dynamo, after you've made your ERD, then you think about your access patterns, and you say, how am I going to access this data? Like, if it's users, I'm going to get them by username, or if it's orders, I'm going to get them by order ID, or different things like that. And you actually list out your actual access patterns. And there are a couple of different ways you can do that. Maybe you work with the front end and back end, you go through the different screens and say, what do I need? Or if you have like a REST API, you can actually just work through the different endpoints you're going to have and say, okay, here are my access patterns. How am I going to handle each one of them? Once you have those access patterns, that's when you start designing your table in DynamoDB, and you're saying, okay, I have this entity, I need to access it these 3 ways. So I need to make sure those are built into either my primary key or my secondary index somewhere, so I can handle that access pattern. So you're really designing your table for those access patterns. And then some people get nervous because they're saying, what if my access patterns change down the line? What am I going to do? Do I have to redesign my whole table? I cover that in the book as well. But usually you can handle that in a pretty straightforward way. A lot of the ways are what I call additive, where you can just add it into your table. You don't have to change any existing items, and it's going to work. But even sometimes you do have to manipulate existing items and add new attributes to them, so you can index them in that way. Even that is a pretty straightforward process, and there are some tips for that as well.
Understood. So last question before we conclude the session. Have you seen any difference between modeling it with the REST APIs and GraphQL?
Yeah.
The whole structure is different, right? When it comes to REST, there are single endpoints and single calls, right? When it comes to GraphQL, you'll have a single interface which is going to make multiple different, calls in different criteria.
Yeah, it's that's a great question, and I've had a lot of people ask that when I talk about it. I would say, it's a little more difficult to do some of the really great single table design stuff with DynamoDB and GraphQL, because a lot of what you're doing with that single table design in Dynamo is you're saying, how can I arrange my data so I'm making as few requests as possible to the database to handle this particular access pattern. But then, GraphQL blows that up because you have sort of different access patterns depending on what they're accessing. The one thing I would say is I think that problem exists in GraphQL, whether you're using DynamoDB or a relational database or anything else. I think there is that problem, not just of the N+1 problem, but just like, I have sort of a waterfall of requests that I might have, and it's going to take a lot of, hits to the database. So I think you can do DynamoDB with GraphQL, and a lot of people are. A lot of people are using AppSync to do that, and I think that works great. But a lot of people are using other things as well. You can do it. You're going to have the same problems in GraphQL that you always have. Like how sort of a deep of a waterfall request do you allow?
We have a DynamoDB where we have a central, we could use the whole database in a single table as well, right? That's something that we could do in DynamoDB as well. And with that, if you have multiple REST endpoints, okay, that's gonna give you a single calls. But when it comes to GraphQL, I can, kind of work out different configurations on GraphQL side as well. So that's where the question was coming towards that, are there any modeling changes that you do when you pick between REST and GraphQL?
Yeah, but I would say the biggest change is I'm a little less of a single table design zealot on GraphQL, just because it's likely you're going to have to make multiple requests as part of GraphQL anyway. So then, the whole point of single table design, and most of it, is to fetch multiple different types of items. Get the parent item and its children in one request, which is more efficient. But if the way GraphQL is designed, it's you make one request and then you satisfy the child resolver and make more requests, and then the child and more requests. Like, you've lost some of the benefits. So I think I'm more willing to say, hey, go ahead and use multiple tables if you want to.
So what do you prefer, single table or multiple tables on DynamoDB?
Yeah, I prefer single table for my stuff. I don't do a whole lot of GraphQL. And it's a process. The biggest thing I would say is I think it's worthwhile to learn single table design and how it works, because I think you do learn how to structure your table for DynamoDB. And then even if you're saying, I'm going to do multiple tables, you at least understand the principles of trying to reduce how many requests you're going to make, trying to make them in parallel if possible, how you index things. You're not using an auto-incrementing primary key for your identifier. That's not useful to you. You're indexing on something meaningful, like a username or something else. So, at least learning those principles. But if you want to opt into a little bit more tables, I'm not gonna give you too hard a time for it.
Because this question is coming from a guy who is planning to move stuff from RDS MySQL to a DynamoDB down in the future. But I've been hearing a lot of discussions about moving to a single table design where all the stuff should be planned in a way that you will have a single table and you can query based on sorting keys and primary keys and secondary keys. These three things should be able to pull you out from everything.
Yep. Yep. It's true. It's true.
No problem. So thanks a lot for your time, and I know how much energy it takes to record a video and then push it through, and I know you've been talking to a lot of different meetups and different user groups, and you've been recording sessions individually. So I really appreciate the time you have taken out for our community and for this channel. Okay.
Yeah, you're welcome. Thanks for having me. I love doing this, so I appreciate you having me on.
Thanks a lot. Thanks a lot again. And I think we are near to the end of our session. So guys, if you have any questions, you could reach out to Alex on Twitter and the details that he has given to you. And other than that, he has written the whole book on DynamoDB. DynamoDB, where you could find out more details on different patterns that we could use with DynamoDB. Okay, so thanks a lot, guys, everybody, for tuning in, and I'll see you guys again next week. We have another AWS serverless hero coming in next week, which is Dhaval Nagar, our very own, from the same city, as from where I have, grown a lot. So I'll see you guys next week again, same time, 7 p.m. Thanks a lot, everybody.
Yeah.
Hey, Alex.